Hello, hello. We are now live. Welcome everyone to this session, to this webinar session. Some of you already know me. Hi, I'm Carlos. I'll be your host today. And today we will approach on accelerating carbon projects, this webinar. So leveraging satellite data for rapid feasibility studies. Actually, this is one of the most expected sessions that we have recently. For 1 p.m. CET, we'll give, as usual, give you guys some time so we can give everyone the chance to arrive. I can see a lot of people coming in already. We are now at almost 80 people joining and increasing. So we'll give you around 5 minutes to allow everybody to connect to the session. Okay. In the meantime, I would like to give the chance to our speakers to introduce themselves. So I will start with our special guest, Annette, today. You can see that Annette is with the camera off because at this moment, unfortunately, Annette's having some connection issues, but she will be here with us. And welcome, Annette. Great to have you here today.
Hi, everybody. I will give a quick hi. Hello from Uganda. And my main reason because I'm joining without the camera is because of due to the weather conditions, data connection is not so stable. This is our day-to-day challenge in East Africa. So my name is Annette Garoza, as mentioned. I'm one of the co-founders of 1MT Nation. I'm international climate lawyer. My expertise lays in afforestation projects and agriculture projects. From the second hat, I'm also ambassador of Africa in international impact investor network called Top Tier Impact, and with my legal background, helping African countries to help their formalize their climate regulations. But today we will focus on the first hat. I'm super excited, and I would love to engage in the discussions. Please ask questions. I'm looking forward. Thank you.
Thank you, Annette. And now, debuting in our webinar sessions, my colleague here at Orbify, our Earth Observation Engineer, Antonios. Welcome, Antonios.
Yeah, nice to meet you all. So I am Antonis. I come from Greece, from the tropical island of Crete, and I am a remote sensing engineer. I have recently joined Orbify, and I have huge experience with working in this remote sensing field. And I'm happy to present and participate in this webinar.
Cool. Thank you, Antonios. Well, guys, now that you've met us, we would like to know a little bit more about you. So drop in the chat. You can see the chat in the right side of the page here. Where in the world you are? I can start. Hello, guys, from Portugal. Let's see.
I already mentioned that I'm calling in from Uganda. Laura is asking if I'm in the field. No, Laura. Unfortunately, I'm not in the field. I'm in Kampala. Our field is near Gulu in northern Uganda, but I must admit I would love to be there now to see our project happening.
Awesome. Well, I can see. All right. Brazil, Uganda, Chile, Malawi, India, France, Mexican in France also, Castle Rock, Colorado, Estonia, Sardinia, Italy, nice, Philippines, Austria, the Netherlands. Well, we have a global audience today, as usual, actually, in our webinars. We are reaching a lot of people from all around the world. All right. Okay, let me see how we are here. Okay, almost there. Well, we are almost there, guys. So it's time to launch our first poll today. So we would love to understand what role best describes your involvement in carbon projects. So you're gonna see the poll in your screen right now. So during the webinar, you're gonna see some polls popping up in your screen. So please engage with that. If you don't have if you cannot see your answer in the screen, just drop in the chat. And this is it. Let's see. Cool. 28, 34 answers. All right. Nice. All right. Okay, so I would like, so we are ready to start. Just to share with you guys how it's going to be the flow of the webinar. So we go first with Annette with her presentation. And as usual, afterwards, we have the Q&A session. So please feel free to drop your questions in the chat during the, you don't need to wait until the end of the presentation, just drop the questions. We can mark the messages as a question in the chat, and in the Q&A sessions, we can go through all the questions. So feel free to drop the messages, engage with the webinar, and that's it. Okay, now, Annette, the stage is yours.
Great, thank you.
Okay. Can you guys see the screen, right?
Yes, let's kick it out. So today I wanted to maybe not stick with the webinar's theme as it is, but to give the theme as unlocking nature-based carbon removal potential. Because by being with boots on the ground experience currently with you in Uganda, having our first project operational, we have, of course, there's been a lot of tough lessons along the way, but we see how technology can help us move forward more precise, more faster, more gaining insights. So this is the theme. What I want to just to really emphasize: unlocking opportunities and potential. There is so many opportunities in nature-based solutions, but it depends how we develop them. If I can have a next slide, please. So a little bit about my background. I'm one of the co-founders of a company called 1MT Nation. We are nature-based carbon removal project developer in Africa. We are operational in Uganda. As a company, we have a very big goal. We want to restore 1 million hectares of degraded land by year 2030. This is a very big and important goal. But to make this really happen, we need to make sure that we implement and use the best technology out there possible to prove the transparency for our project and also the high quality. We are using a tool called, we call it bamboo, for this land restoration, along with the biodiversity management practices. We are planting native or naturalized bamboo in the area. And we are also working together with the local communities hand in hand, because we are using their biggest asset. This is the land. That's why we want to be sure that from the regulation perspective, from the legal perspective, from the environmental and also from the social aspects, we are not doing harm, and how we can make sure that we are not doing it. If I can have a next slide, please. So I put a quick question, MRV, why? So 1MTN, we are developing our project under the BERA certification. Each carbon standard, of course, has their different regulations, what we need to be compliant, and voluntary carbon market, there is no questions about this, that it has had a very bad publicity lately, and of course it's due to the lack of the technology use and to very bad practices along the way. So with our operations in 1MT Nation, we use Orbify. Thank you, Orbify, for being our partner in this one, to look the land potentially the land to assess the project baseline, to look at the vegetation, to look at the forest cover, yearly deforestation rates, also the biodiversity data. In the future, it would be very exciting add-on for our reports. At the moment, we have been using it as a base for our start when we are looking at the new project instances. We really like this approach that we have one report, and also that we can share access to external third parties who wants to validate where our project has been developed. So it's good that we have some kind of outsourced tool where the information is gathered at the one place. So you see here our first project site. It's called Nuoya. This is where our operations are already happening, and we are very happy that by using MRV we can improve the quality. We can improve the quality of our project documentation. It's uncomparable to the 5 years ago VCM market standard, I would say. Next slide, please. So regarding the MRV, I wanted to say that it actually goes all together, and I am tying up together the SDGs, and I wanted also to showcase you that our project starts with the project site. So this means that with the project site, we need to be very careful how we are accessing and what kind of land we are choosing. Not only from the carbon credit project side, from the regulation side, if we can have this land in a project, what is the deforestation, what is on the land, is it accepted by the standard, but also by the fact that we are using bamboo, and we want to know that the bamboo does very good in this area. So all the information what we can get out of the MRV is very needed, not only from proving the quality, but actually from the operations. And as you can see, the impact is huge in the whole value chain. This is basically our 1MTN business model. And I would love to, if you have any questions, I would love to answer those. This webinar definitely is not for the operational perspective of the business, but I just wanted to give you guys an input how big it is, and that it all starts with the project site and with the land. In our case, that's the most valuable thing, that we need to be fully transparent, and we need to take care of the operations with the lands, because otherwise there is also affected community, and of course in the future regarding the next side of the value chain, there's an off-taker. So we want to make sure that with our carbon project, the biomass, sustainable biomass, what is coming out is really coming out of the area which is degraded, that we establish something completely new, and that we can very also report and align with our mission. Next one. Yes, and by giving just an input and to make this webinar more fun and also more impactful, I just wanted to quickly show you guys like how many SDGs we can tap in regarding the one land nature-based land project, because by implementing different practices, which starts with the land, we are actually touching community, and the impact out of the nature-based solutions it's very big. And we love to say that it actually goes beyond carbon sequestration, but it's actually social benefit what we also need to account for. Thank you. The next one. Yes, and again, by giving this, as I said before, we don't need only carbon neutral, but also nature and community positive solutions. But how can we make sure that it's really nature positive solution? We need to use a tool what could help us to get information much faster, more better quality, because also from the operational perspective, using MRV as a first instance of checking the next possible pilot stages to assess the land prior sending our local team on the ground. First of all, maybe we are reducing our emissions, carbon footprint, because maybe this land is not suitable for our project, meaning that we did pre-assessment, we assessed and also got a report that unfortunately this land is not going through with our requirements. From one perspective, yeah, that's not so good. From other perspective, great. We are not sending operational team on the ground. We are actually taking care of our carbon footprint. On the second way, also regarding the local team and the local operations, yes, by collecting the data on the ground and having a large scale operations can be a lot of mistakes involved, and we want to avoid or minimize the risks of mistakes. So everything what we can analyze through the satellite, it's in our case we see that as prior activity, and that's why we want to emphasize the nature positive solutions. The next one. And thank you, guys. That's the final one. I know that I was super quick, but my approach usually is I love to answer the questions when they are, because this is the input from our perspective as a project developer, what we can answer by being boots on the ground. And if you have any questions, please feel free to ask in the chat. Thank you.
Thank you, Annette. This is a really nice presentation. Guys, so this is time for the questions. This is the Q&A session for our first presentation of the day. Please drop the questions in the chat, and Annette will go through all the questions. Okay, we have the first one, Annette. How do local, international environment and land regulations impact your operations in Africa?
As I understand, this is more to the carbon regulations. Of course, it affects directly. I would say that by implementing the project, let's touch the first hard aspect, climate financing. Without exact regulations, the climate financing, access to the climate finance is pretty hard to get. Let's be completely honest about this one. The second one, I think that at the moment in Uganda, I see a very good development with the private sector involvement. Also today we had another in detail the question session with the draft regulations where private sector can add their concerns and also implement different suggestions by being operational on the ground. Of course, that's very, very important for us because that can kill a business or that can scale up the business. And we want to showcase opportunities, meaning that it can direct, of course, it can impact directly operations. Yes. Then next one, can you please share some?
Yeah, sorry. Yeah. And then can you please share some insights on the certification process with Vera?
Yeah, that's not been an easy road. I have experienced myself with Vera for 6 years, and also by having a lot of feasibility studies with different projects. Then with our team, we decided to do our own approach to go some steps further than actually requirements are asked. And at the moment, we are in a validation process. And it's not been an easy road, because the new methodology were out with the delay, meaning that it affected our project operations directly a lot. It delayed a lot, and of course it's not good. But so far, I think that also Vera is on a new path, and I would be very curious and happy to see how they prove their credibility in the future.
Cool. So next one, how you ascertain the land ownership and ground truthing of the field data?
So we take land ownership is one of the biggest hard points in every project. We are at the moment using only titled privately owned lands. And the reason behind this one is that at the moment we see there's great risk factors in different land tenure systems in East Africa. In Uganda, with our first project, we chose to go fully in at the moment by leasing the land from the private landowner. Also doing additional land boundary opening, another surveillance, another title registration, and registering in the end or land lease title and in the public registry. We didn't, so of course this process is not easy. It's lengthy and costly. At the moment, by being a lawyer, I must admit I'm very careful with all the projects which are nature-based, and we need to be careful that there is no land issues. This is our approach.
Cool. Next one here, how much is paid to landholder?
Yeah, this is I can say the metrics. So and we are accessing different areas. That's the reason why I said also during my presentation that it's very important that we are using MRV tool with the prior land assessment, because firstly we need to save our operational teams time, costs as well, to assess if this land is even feasible for a project. If it is, then we need to do another assessment and to get data of the land leasehold prices in the region. Also in Uganda, different regions has different land lease prices per hectare, and we are paying more per hectare than the regular price, and that's also part of the landowners involvement into the carbon project, and it's paid on an annual basis.
Nice. Yeah, we have a few more questions here. Well, from Santonu, I was wondering if and when you harvest and how do you make sure the carbon continues to be stored?
This is a great question. I was waiting for this one, and we have a holistic view on this one. First of all, actually, the permanent starts already with the seedling nurseries. Our team is spending a lot of time and also doing nursery audits on a b-week, sometimes on a b-weekly basis. We also designed our own standards for the nurseries, how the seedlings are developed. We see that this is very important in the future to make sure that the bamboo plantations are basically healthy, because well-maintained bamboo plantations can be also up to 100 years. Second of all, we are not harvesting it for commercial purposes. We are harvesting and doing the selective sustainable harvesting, because if we don't do it, bamboo plantation is not healthy. We have to do it. And regarding the biomass which is coming out, we are not doing it ourselves. We are scoping out the partners, and we are making sure that the way how the biomass is treated is also sustainable. At the moment, we are looking at construction materials and biochar.
Perfect. Thank you, Annette. Next one, we have more 8 questions here. We have time yet. So do you use the MRV throughout the measurement and reporting periods, or do manual measurements at certain intervals?
Yes, this is the hard reality. We do a lot of manual measurements still, soil data sampling, bamboo sampling still. Bamboos are growing very fast, and we need to assess more precise data regarding our forest inventory. And there are still a lot of manual data collected. And this is the things how to collect it. Regarding if there is no internet access, then we need to make sure that the operations can handle, for example, connectivity loss for 5 to 6 days. So still, that's true. Our operations are not feasible only with MRV. We need operational team input a lot.
All right, next one. Do you use the satellite imagery in any other ways other than establishing the base for the project?
Fire monitoring, if I can say that, that's also a possibility to use. We love to assess also deforestation rates in area because, as I mentioned before, our projects are developing sustainable timber. Northern Uganda is very vulnerable for the deforestation. The way how local people are cooking the food is using the firewood. And we want to do the research in the future regarding how sustainable timber could possibly reduce the risks to the nearby forests. Could that be solution in upcoming future? We don't know it yet. We are establishing our educational research partners at the moment to really assess the in-depth research regarding this topic. But the question is very good, and that's true. We can use the satellite imagery not only from the project-based establishment, but also from the operational perspective as well.
Cool. Thank you, Annette. Just for the sake of the time, guys, let's get a couple of more questions and then move forward to the next presentation. But I promise you guys that we'll have all the questions covered. If not in the session, we'll send you guys afterwards the answers. By the way, I got some questions here in the chat asking if the webinar is being recorded. And yes, so tomorrow you guys gonna have the recording in your email, and also you can find on our website and on LinkedIn. Okay, so next one. What methodologies are used for satellite carbon monitoring?
So regarding our project, we are using the new ARR methodology from Vera. Nothing else regarding the carbon accounting.
Right. Next
I see a very great question. I think, sorry, Carlos, I need to address it, but there was a question regarding biochar. Are we double accounting? No. Biochar for our project is still under the research phase, because our plantations will develop more or less significant biomass after 4 years. So we have time to assess this one, but I would be very careful to putting another carbon project on top of it, because we need to make sure that we are not double accounting as well. And in the future, in upcoming years, I cannot comment how the ARR methodology will assess the outcomes.
Cool. I think we have time for one more. Well, just to mention this last question, guys, is the Santono asked, right, Annette? This, if you make biochar from the bamboo plantation, this is the last one.
Yes, correct.
Yeah, I think we have time for one more. Just following the order here, it's this one. How do you select the vegetation species for your ARR projects? Are you primarily interested in fast-growing species, or do you prioritize local species regardless of their growth rate?
So first of all, we are using only native or naturalized species, and actually this gives us not so many options. So yes, bamboo is native for Uganda, but this is the reason why we developed in-house our site species matching tool, We have the species, what we want to use, and then from this, when we have selected the native or naturalized species, then we can choose and select in specific area after we have assessed the land using Orbify. We are putting the same land into our site species matching tool, and then we are assessing which species, how we will plant, because we are also using mosaic approach. And this is on operational side, it's quite heavy. We need to make sure that the bamboo nurseries will really match also the supply for this.
Amazing. Thank you, Annette. Guys, I know that you have a couple of more questions here, but just for the sake of time here, let's move forward for the next presentation. If we have time, we can go over the rest of the questions in the end of the session. Otherwise, I promise you guys that we will check with Annette here a way to answer all the questions for you guys afterwards. Okay, and yeah, that's it. Antonios, yeah, stage is yours.
Thank you very much. So I think you can see my slideshow, right?
Yes.
So you can enable the spotlight and we are ready to go. Yeah, perfect. So hello to everyone. Once again, I'm Antonis Kontroubas. I come from Greece. I'm a remote sensing engineer. And today I will talk about how we can use the satellite data in order to facilitate and accelerate the carbon offset projects. So as you may know, every day we witness the climate change and the global warming of the planet. So we release a lot of carbon dioxide at the atmosphere through the human activity, from driving to using energy and making food. So it is super crucial to find a way to reduce these carbon emissions. So basically, the carbon offsetting, to put it in simple words, means it's a way to balance out the carbon emissions by reducing them elsewhere. Carbon credits are certified through businesses in order to avoid and cut emissions. So we have carbon offsets projects in forestry that encompass both removal and avoidance strategies, targeting existing emissions and preventing future releases into the atmosphere, respectively. So companies of offset carbon emissions, they are buying credits in order that represent the avoided and or the sequestered CO2 by supporting initiatives like afforestation, reforestation, and improved forest management. Even though they have to face a number of challenges when it comes to non-permanence and additionality of those projects. So mainly we have three forest carbon offset projects. We have the reducing emissions from deforestation and forest degradation, which is, in simple words, how to protect our forests and reduce the deforestation activities within them. The Afforestation and the Reforestation and the Revegetation projects, which basically is to grow, as my co-presenter Annette talked about previously, how to grow new trees within a forest, which are able to trap the carbon dioxide and store it within the biomass. And they improved forest management projects, which basically introduce a better management of the forestry, of increasing the amount of carbon stored in the biomass or reducing the emissions. So before we talk about investing into a carbon offset project, we need to address some questions like, okay, what would happen to that specific area if the project didn't exist? Will that area anyways will reduce the carbon emissions or not. So also if the project will add value in this procedure of reducing carbon emissions from the atmosphere, how long my project will last through the years, and how much carbon is already present in the area of the project. So basically, those questions can be answered through having better insights and a bunch of information that are useful in order to answer these questions. For example, in order to find and select which is the most suitable area, land cover maps help a lot and elevate the decision making. Also, the forest status regarding what is the actual health of the forest. Are the trees sick or not? Within the framework of baseline and vertification, we need to have insights and information regarding the historical deforestation events that happened not only within our project area, but also having an idea of what was happening around the project. Also, information related to the canopy height, the above and below ground bias, and the organic carbon that's found within the soil are properties that are related to the carbon stock. So these factors, these things are very strongly related to addressing the baseline and the vertification. And in respect to additionality and permanence, it's super crucial to have an idea of the accessibility of the specific area that we conduct our analysis and we want to invest in a carbon project, right? So we need to know how easy is accessible is that specific area, how near is the infrastructure, the cities, if this area that we want to invest is going to be a protected or not area, and elevate the insights, having an idea of historical events of natural hazards phenomenon, like the occurrence of fires, floods, and the drought season. So how we can solve and how we can answer to all these questions? Well, right now we're living into the satellite era. For more than 30, 40 years now, we are launching satellites into orbit, and we are able to observe Earth from above. We're having right now a huge variety of more than 3,000 satellites in orbit, equipped with different kind of sensors. We have from sensors that are able to capture the light reflectance on the Earth's surface with multispectral and hyperspectral technology, up to using the existing radar technology in space. And all these sensors can bring and elevate our understanding of the activities that happen on the Earth's surface. And right now we can have insights in global scale. So satellites cover all Earth, right? So they orbit around Earth and can give us information regarding properties of the Earth, like where are my forests located, how near are to my cities, where is the infrastructure located, and where are the water bodies of it. And this is super crucial into carbon offset projects. We can also get meaningful information regarding the health of the vegetation, as I said before, by just looking at the reflectance at different bands, which are smaller spaces of the electromagnetic spectrum. We can understand the dynamics of the health of a forest. And we can also monitor Earth from above. So even with the naked eye, looking at a specific area, we are able to capture significant changes of the land use. And thus, we are able to see the deforestation activities that happen not only on one specific time step, rather than going back in history and being able to understand and see how Earth looked like some years before. And this is also possible not only by using optical satellite data, but also using more sophisticated radar technology, which is, I know, a bit tricky to comprehend and understand, but generally this technology overcomes a lot of limitations that we face with the optical images. And it can provide accurate results into our analysis. Apart from those, we are able to provide insights and information regarding the canopy height. So we can say how tall a tree is, right? And we can monitor our forests, and we can tell from the height of the trees how we can correlate those information with the carbon that's found within them. And not only that, right now, the technology, especially in the satellite industry, has pioneered a lot, has done huge steps. Right now, we are able to capture the above-ground biomass, which lies within our forests. So not only by having information regarding the ground mass that is found on the tree canopy, but also having information of the biomass that is hidden in the branches of the trees. And also what can happen, the biomass found in some centimeters in the soil. This technology, this necessity of having this kind of information was super crucial also for the European Space Agency that launched a satellite constellation into orbit some months ago, which is specifically dedicated in how we can measure accurately the above-ground biomass through a very innovative technology of a new radar sensor. And by the moment we can calculate the above-ground biomass, we can easily then convert it into carbon content, right? By establishing the biomass to carbon conversion factors. So how satellite data can elevate the existing carbon credit market? Well, first, they enhance the efficiency. So, as I said, we monitor Earth from space, and that means that we can capture information worldwide in a global scale. And this also offers transparency into our projects. Not only we focus on a specific area of a carbon offset project, rather than having a better picture and better understanding of the dynamics and the activities that happen, not only at a very specific time range, but rather than historical events in a huge area. So this can provide standardized data on the carbon stocks and emissions. Apart from that, right now we have non-commercial satellites which are publicly available. And this is a super cost-effective solution that reduces the amount of costs significantly compared to the ground-based surveys. And at the same time, improves the accuracy of this analysis. How? By introducing a variety of data. We are not talking about only forests. We can have data that are related to above ground biomass, as I said, to the canopy height, to fire risk mapping, flood risk mapping, and so many different data sources from different platforms that can integrate it and give us a better understanding and more sophisticated way to see things. which at the same time, this is a factor that accelerates the decision making and the investment in the carbon offset projects. Well, all those are amazing, but at the same time, of course, we face some limitations when it comes to the satellite technology. So basically, we send satellites into orbit almost 30 years now, and those satellites were a bit old. They are a bit old right now, right? So the images that we capture through those satellites are not in the best quality. They are a bit of low quality. So history can be addressed through satellite data, but it depends also on the analysis on the problem that we want to solve. So if our problem is that we need to have super accurate, high resolution images, then we may face a small problem when it comes to history. And of course, when we are talking about optical satellite data, we have the most common problem of cloud coverage. Well, as far as you know, light cannot penetrate through clouds. So these passive optical sensors, they cannot capture the light that comes back from Earth through clouds. And this limits a bit the analysis that can be done. Also, the revisit time. Okay, so now I need to clarify a bit what I mean by the revisit time. If you just look at a very specific area on the planet, you want your satellite to come and capture data after some days, right? So right now, the non-commercial satellites have, at the best case scenario, 5 days of revisit time. So I can capture data at a very specific location every 5 days. And bear in mind also that we have the cloud limitations. So that can be a bit, difficult when it comes to this high importance analysis. And the resolution, of course, which is basically, let's say, 1 pixel of one satellite image, in what area does it correlate? So basically, the best case scenario in a non-commercial satellite image, it will be 1 pixel corresponds to 10 by 10 meters of Earth area, right? And that can be useful, but also if we want to monitor something that is more in the parcel level and not in the large scale, like monitoring the forests in the national, for a country, for example, can be a bit tricky. And of course, the computational complexity. As far as you may understand right now, satellite data is a big data problem, right? And this introduces a lot of problems into analysis because we need to take into account the complexity of the computational power that we have to face. The good news here is that since the technology involves day by day and new cool stuff come into this Earth Observation Society, right now we have solutions of distributing computing systems, and we can use also cloud infrastructures in order to solve this big data problem. And, and this is like a small comparison when it comes to the challenges that we face with the usage of satellite data into REDD and ARR projects. So let's keep it simple. REDD projects are mainly monitoring the existing forests and their characteristics, right? So this is more of a, let's identify a forest to non-forest problem. This is quite straightforward. It does have some complexities, but it's not significantly difficult to address it. Whereas when we have the ARR projects, they address more than what is the forest growth and what's the plantation success. So when we have trees that need at least 10 years in order to mature, that, as you can imagine, can be very difficult to address. Of course, we can have a monitoring system, but then the results are going to be not that accurate. it's very difficult to capture small changes, especially having monitoring the vegetation growth. Within the same framework, I already talked about the limitations that we face with the cloudy areas, right? But we also have some other tools in our toolbox, so we can use and utilize radar along with optical data integrated in the same system in order to provide analysis and estimates which are meaningful to carbon offset projects. And at the same time, we can also use commercial satellite data. They come with some expenses, they cost more, but the higher the resolution that they offer to the satellite images is huge. We can even have an image of 50 centimeters of spatial resolution. And so we can see things in a better way. And lastly, the above ground biomass estimation. So this can be also be tricky, especially when we are talking about the above ground biomass estimation in the global scale. There are some areas where the accuracy of the estimated above ground biomass for many factors, it's not that good. So we face missing data. What we can do, we can use the new technologies of machine learning and deep learning in order to train models that will be able to predict the above ground biomass values at those specific missing areas. So yeah, we have some solutions, and basically that was my presentation, and I will be happy now to answer your questions.
Okay. Nice. Thank you, Antonios. So time to questions. Let's go over the first one. What sensors? Just one thing that I was almost forgetting. We have a special guest here for the Q&A session, which is he is joining the stage. It's Jakub, our CEO. He's joining, but I can go just for the sake of the time for the first question here. Hi, Jakub is here. What sensors do you use to capture above ground biomass, maybe data sets or something?
Yeah, so basically there are many different ways to capture the above ground biomass. If we put aside the biomass satellite constellation, which is super promising and can elevate the existing accuracies, the previously analyses were based on finding the correlation between optical and radar data with in situ measurements. So we could have in situ measurements having the location and the data that those measurements were conducted, and we would build a model on top of that through the reflectance of satellite images and from radar sensors with SAR backscatters in order to construct a model that will be able to predict through machine learning. It could be from a random forest to, a more simple model.
Cool. So next one, I can see here that we had a discussion here in our chat, Alex and Santono. Alex said, satellite is not accurate. Why not use LiDAR and industrial drones?
Okay, yeah, that's super good. Nice question. LiDAR technology is an awesome technology, but it's super expensive. It's also mainly right now used by having these LiDAR sensors on top of an airplane, right? And that limits a lot the availability of data on the global scale. So if someone wants to monitor have insights and solutions on a specific area, that would definitely elevate the accuracy of the results, but it won't be a global solution.
All right. Next one. Remote sensing has to be supported with ground truthing as well. It does not fully replace ground verification. Therefore, overall, I assume this is an added cost to the project, as you said, yes. Is there any data available to show that projects using remote sense-based assessment command higher carbon price in the market?
Can you
Yeah.
repeat? Yeah.
Okay, just for the question, is there any data available to show that projects using remote sensing-based assessment command higher price carbon sorry, let me read again. Is there any data available to show that projects using remote sensing-based assessment command higher carbon price in the market?
Okay, I'm not quite sure that I understand the question, but I would say that, okay, for the first part, definitely we need in situ and field measurements, right? Why? Because they're the most accurate measurements that we can have, and it's the only way that we can measure the accuracy of the satellite solutions. So when it comes to the costs, I don't think that satellite data introduce more costs into the analysis, rather than reducing the costs and narrowing down a bit the amount of data that needs to be gathered through in situ measurements.
All right. How do you translate canopy height data into above ground biomass? Do you still need field data?
Okay, these are two things that correlate with each other. We do use models that are released from forestry and combine those two. If you need more technical detail on this one, I need to come back to my team.
All right. How the cloudy area can be replaced using radar dataset?
Okay, that's also tricky. So radar data do not have this problem of not penetrating the clouds. So basically, there are different approaches. Most of them are using deep learning approach techniques in order to answer this question. So by coupling time series of satellite images along optical ones, along with radar ones, you can find, you can generate, let's say, trustworthy data. They are not actual raw measurements, rather than you generate some trustworthy fake ones. But since you are using different kind of sensors, it elevates the accuracy of the output.
All right. Yeah, we have time for a couple of more. Is all coding running on the Orbify platform, or do you run the model on an external software?
I mean, we use Python, so we do train our models using Python, and we visualize them through Orbify's platform.
So maybe the question was more about infrastructure. So Orbify is hosted on both Google Cloud and AWS, if you're interested in those details. But, well, I'm not sure if this is super interesting to that many people on the call. So if you are really interested in knowing more about Orbify infrastructure, please reach out to me, jd@orbify.com, and I'll be happy to give you all the technical details. But I just don't want to waste everyone's, well, not waste, but spend everyone's time on discussing those technical details. But,
cool. Thank you, Jakub. I think we have time for one more, and then we go to the closing. What's your view in utilizing satellite data for forest inventory to get country-specific emission factors?
Can you repeat the question, please?
Yeah, sure.
I don't think I did. Yeah.
Okay. Let me see, because sorry, okay, here. what's your view in utilizing satellite data for forest inventory to get country-specific emission factors?
Okay, I mean, the good news is that the satellite technology is getting updated and advances every day. Even I don't know how many of you are already into this space industry, but videos that can be found in different platforms that are 1 or 2 years old. Right now, we do have this technology, which is kind of amazing how this technology speeds up and we get the results. So I think that we can have a forest inventory in the near future and can be also used and the countries can be relied on it, right, for the specific emission factors.
All right, thank you, Antonios. Guys, we are over time right now, 1 hour of session. Thank you guys so much for being here. Thank you, Annette. Thank you, Antonios. Thank you, Jakub. This is it. I promise you guys that the questions that we couldn't answer today, we'll go through it offline. Tomorrow, don't forget, you're going to receive the recording on your emails, website. You can follow us on LinkedIn as well. I'm just dropping the chat Annette's contacts. So if you want to reach out to Annette, this is her contacts and the 1 Million Trees website. Also, our contacts at RBFI website, LinkedIn. And this is it, guys. Thank you so much. Thank you so much, guys. And soon, really soon, in 2 weeks, probably we're gonna announce our next webinar. Stay tuned. And that's it. Thank you, guys. Have a great day, and we'll see you next time.
Yeah, thanks to all attendees for staying with us, and big thanks to Annette, big thanks to Antonis for presenting those topics. Have a great afternoon. Take care. Bye-bye.
Thank you, guys.
Bye-bye.